Welcome to Study Loop.
Okay, we have an anhydride substituted with a phenyl ring on one side and a methyl group on the other. And we're reacting this with acidic water, or H3O+. And so what does an anhydride do when we react it with acidic water? It's going to separate into two carboxylic acids, right? Effectively, the oxygen will become protonated. This isn't the full mechanism because that's not required for the problem. The oxygen will become protonated. A molecule of water left behind from the acidic water will then attack whichever carbonyl is more electrophilic, which in this case would be the methyl substituted side, right? And that'll generate the tetrahedral intermediate, which will push back down and kick off the carboxylic acid effectively. So if you want to think about it systematically rather than step through the mechanism each time, here is the trick that you can do. So I'm going to draw this anhydride again. And this will work for any anhydride. Right? So the way I like to think about it is cutting one of the bonds. It really doesn't matter which, okay? And then think about that we have our acid over here. So I'm going to draw it as H and then OH2 plus. Okay. And so what's going to end up happening, actually I may draw, let me do two different colors here. I'll do green for this side. Okay, so the left-hand side with our phenyl substitution is going to have that the oxygen will end up with the proton from the acid, right? And then what's going to happen is that this green oxygen is actually going to end up attacking the carbonyl during the course of the reaction. So we're going to get a new carbon-oxygen bond for that side. And that will generate a new carboxylic acid. And then notice that this is OH2. Basically what's going to happen is that we're going to maintain one of those protons as simply a bare proton, but if we're doing this reaction in water, as is often the case, we can think about it as that we'll still have H3O plus left over, or that the acid is purely catalytic and not consumed during the reaction. But in terms of the products, the major organic products, you'll note isn't that important as far as side products go. It's not part of the question. What we need to pick is the answer that gives us two carboxylic acids. And so that would appear to be answer E, right? Because they're saying phenyl ring. And they're saying CO2H, which is the structural formula abbreviation or condensed formula abbreviation for carboxylic acid. And then they're saying methyl with CO2H. Once again, that's the condensed formula for a carboxylic acid.